What's up, guys? This is Walid in here. Today's problem is the conduction in series and parallel, as you can see in here. So we have two metals. We have the copper, we have the aluminum, and there's this on the sides, which is 20 Celsius and 100 Celsius. So the first question is, what's the thermal resistance of the copper cube? Okay, so if you want just a quick answer, R will be equal to X divided by A times K. If you want to know how I got this one, well, normal current is equal to V divided by R, okay, which is the same as delta V in here. And the thermal current, I thermal, or they can call it also P, is equal to K A delta T divided by L. Okay, so just make this term similar to this one. Will come I or P equal delta T divided by L K A times A. This is the area. Okay, so this term is going to equal the R. Okay, thermal resistance of it. That's where I got it. So X here is also equal to L. Okay, L is the cube. Let's pull it out. L is what's the edges of this cube. Okay. Same thing for number 2. So it's going to be R equal X divided by A times K. Both of them has the same area and same X, and then the K is just the you gotta find it for the aluminum and for the copper. Number 3 is, what's the thermal resistance of the combined cubes? Okay, so since they are in series in here, then you just add them together. So let's call this R1 and this is R2. So R1 plus R2. Okay. So number 4. Number 4, what's the thermal resistant? What's the thermal current through the two cubes? Okay. So thermal current. So we're gonna do I is gonna be equal to delta T divided by R. Okay, so since it's going through the same both of them, so when you look at it like current wise, the same current is going to go both of them. Okay, we're going to add them together. That's the resistance in here. So delta T is going to be 100 for me, 100 minus 20. Okay, so 100 minus 20 divided by the total resistance. I'll call it R1 plus R2. Okay, and this is how we get the answer for this. So number 5, what's the temperature at the interface? Temperature at the interface. What we do is the Qn is going to be equal Q out. Okay, which is going to be equal to T1 minus Tm divided by R1 equal to 2m minus T2 divided by R2. Tm is the temperature in the middle. Temperature in the middle in here. That's what we're trying to find in here. Okay. So temperature 1 is the 100 minus the middle, and the middle minus the other temperature. Okay, and these R's. So number 6. Number 6, now we have them in parallel. Okay, so they're asking what's the total thermal resistance in the two cubes. So we just would do 1 divided by R1 plus 1 divided by R2, and they just take the inverse for that. Okay. So number 7, What's the thermal current through the copper cube? Okay. So what we do in this case is do I is going to be equal to delta T divided by R1. Okay. And then it's all going to be, so for me it's 100 minus 20 and then divided by R1. Okay, this is for the, we said the copper is R1. Copper, yeah. R1, this is for the copper. R1 copper. This is what you get from answer number 1. And then for number 8, what's the thermal current through the aluminium cube? Same thing we do. I aluminium, RCU, delta T divided by R2. It's going to be equal to 100 minus 20 divided by R2. This is the answer for number 2. I messed that up. There you go. And then number 9. What's the total thermal current between both cubes? What's the total thermal current between the two cubes? So we just add them both together. So I total will be equal to the sum, which is ICU plus IAL. Okay? This is the answer from this guy. This is the answer from this guy over here. Alright guys, if you have any questions, leave it in the comment section. I'll get back to you. So yeah.